In this video, we will learn about the transmission of pressure in liquids, that is the Pascal law. So we know that the liquid pressure at a point of a liquid of density rho at a depth h below the free surface of the liquid is rho g h. Now, from this relation, it is clear that for a given liquid at rest, the pressure difference between the 2 points depends exclusively on the difference in the vertical height between these points. It means that if somehow the pressure at one point of the liquid is increased, then the pressure at all the other points will increase correspondingly so that the pressure difference between the two given points remain unchanged. Thus, pressure applied at one point of the liquid is transmitted uniformly to all the other points of the liquid. French physicist B. Pascal gave the following law for the transmission of liquid pressure. Statement of Pascal's law. So, whenever an external pressure is applied on a liquid contained in a vessel at one place, the pressure is transmitted undiminished in all directions at every portion of the liquid and to the walls of the container vessels. Now, the experimental demonstration. So, we take a hollow glass sphere having four openings, that is K, L, M, N, of different sizes. Fill the vessel with water and fit a watertight piston on all the four openings as shown in this particular figure, right? Now applying some force on one piston, let's say K, we apply a force on K and push it inwards through a small distance. We find that the other three pistons, that is L, M and N, move equally outwards. On pushing K inwards, we are increasing the pressure there. This increase in pressure is transmitted equally in all the three directions throughout the vessels, and as a result, the other three pistons are pushed outwards. Now, the applications of Pascal's law. Various hydraulic machines such as hydraulic lift, hydraulic press, hydraulic brakes are based on Pascal's law. Although the detailed discussion of these devices is beyond the scope of this book, we are considering the basic principle of hydraulic machine. So what is the principle of hydraulic machine? So it is essentially a force multiplier and works on the principle that a small force applied over a small piston is transmitted through a liquid so as to produce a large force on a bigger piston. Now, as shown in this particular figure, we see there are two cylinders, 1 and 2, of different cross-section area A1 and A2. We can easily see that A2 is greater than A1. Now, these are connected through a horizontal pipe. Now, these two cylinders are provided frictionless and airtight pistons, and an incompressible oil is filled in both of these cylinders. When a downward force F1 is applied on the smaller piston, it increases the pressure by an amount, that is change in pressure will be equal to F1 upon A1. Okay, area is small so pressure will be large. So as per the Pascal law, this extra pressure is transmitted through the liquid, that is the oil, and to the larger piston too. Okay, this results in an upward force F2 that would be equal to delta P into A2. Thus, the bigger piston is capable of supporting a large force F2, where F2 will be equal to delta P into A2. That would be equal to F1 upon A1 into A2. So we can say F2 upon F1 will be equal to A2 upon A1, right? So thus we can say that the force F1, that is the applied force, has been increased by a factor of A1 upon A2. And this is known as the mechanical advantage of the hydraulic machine. I hope this topic is clear to you. Thank you.